Our today's topic for discussion is addressing modes. That is for 80386 addressing modes, which is supported by processor, which are supported by processor. So, whenever we are saying addressing modes, first basic definition is nothing but why addressing modes are required, or what is the basic definition that whenever data is stored at some location, when data is stored at some location, whenever it needs to extract or it needs to be used at that time, which are the methods or how that data extraction will happen depend on that addressing modes are there. So first statement, if you will check, addressing modes indicate a way of locating data or operands. What it means, whatever instructions available for processor, so for those instructions from where data will be available, from where data will be extracted, will be taken, depend on that different addressing modes are there. So basic thing you supposed to remember about addressing mode is nothing but from where data is going to, or from where data will be taken. For example, if I am saying data will be taken from register for specific instruction, so it will be register addressing mode. Okay. We are going to discuss addressing modes, all addressing mode. At that time, we will check with example. But at this stage, or basic concept you supposed to remember, addressing mode indicates a way of locating data or operands. Second point given here describes the type of operand and the way they are accessed for execution and instruction. So addressing mode, what it will describe the type of operand and the way they access for executing an instruction. One example just I will show so that you can relate these statements. For example, if I will take this example, add ex comma ebx. So this instruction falls in register addressing mode. Why it is so? Because with this instruction, whatever data is required, these are two operands. You are already aware about this. So these two operands or these two variables, two data, from where this data will be available, that is nothing but this data will be available from register. Okay. So because of that, this instruction will fall under register addressing mode. Okay. So now we will go through this statement, that is describe the type of operand and the way they are accessed for executing an instruction. So different addressing modes are there, and depend on addressing modes or all instruction will fall in different addressing modes. It may be कि add instruction may fall in register addressing mode as well as immediate addressing mode. Depend on with that instruction which type of data, which type of operands are placed. Okay. The method by which address of source data and destination address of result is given in the instruction is called addressing mode. Okay. The method by which address of source data, mostly two type of operands are required, source operand and destination operand. So here it is mentioned the method by which address of source data and destination address of result is given in the instruction is called addressing mode. Okay. So 80386 supports 11 addressing modes. First, register addressing mode, immediate, direct, register indirect, base addressing mode, index addressing mode, scale index, base scale index, base index addressing mode, then base scale index addressing mode with displacement. These two last one with displacement. We are going to check example of each and every addressing mode and definition of each and every addressing mode. But remember at this stage, 80386 provides 11 addressing mode. These type of questions can be there. That is, This question can be there for MCQ. How many addressing mode 80386 support? Next, first type given, that is register addressing mode. So data stored in a register, it is referred using particular register. Very simple. If in instruction source data and destination data available in register, at that time we can say this instruction represent or this instruction falls in register addressing mode category. Okay. Here, instead of whatever instruction is shown here, add, or for example, whatever instruction given, add EX, comma EBX. Okay, instead of that, if it is sorry, add EAX, comma, if it is add EX, comma, some value is given, immediate value. So it will not fall under register addressing mode. It will fall under immediate addressing mode because in this instruction itself data is available. But as here data is available in register, so it falls under register addressing mode. All register except IP used in this addressing mode. This should be except. The 8, 16 or 32-bit data required to execute an instruction is present in 8, 16 or 32. Why it is given as 8, 16 or 32? You already aware about these register can be 8-bit, 16-bit or 32-bit. But source and destination both should be same. Means if destination is 8-bit, the source should be 8-bit only. Both should be of 8-bit, both should be of 16-bit, or both can be of 32-bit. Here both are 32-bit. So 8, 16 or 32-bit register is given along with instruction is called register addressing mode. Okay, this is very simple example given. Just now I discussed this instruction falls under register addressing mode, but if data is going to change, whatever data placed in instruction, if it will be changed, it will fall in another addressing mode. So I can't say ki add instruction will always fall under register addressing mode. It totally depend on how data is placed with that instruction. Okay, now we will go for next, immediate addressing mode. In this addressing mode, immediate data is part of instruction. Just now I discussed, but still we will go through example. And remember very basic thing, in this addressing mode, immediate data is part of instruction. Direct data is available in instruction. It is not in register or at some memory location. Direct data is available in the instruction. It may be 8, 16 or 32-bit data required to execute an instruction given directly along with the instruction is called immediate addressing mode. Okay, now check. Move AX, 0020. So this is the data which is going to move in, or it will be copied. It will move in AX register. So there is no need of taking data from memory location. There is no need of accessing any register for source operand. Okay. So it is very simple that if data which is required for execution of that instruction, if it is available in instruction, we can say that it is immediate addressing mode. One more thing, here data is available in instruction. If I will modify this instruction as move x comma bx, at that time this instruction will fall under register addressing mode instead of immediate addressing mode. Getting my point? If instruction move x comma 0020h, instead of that, if I am writing move x comma bx, at that time this instruction will change from immediate addressing mode to register addressing mode. So here also syntax is given, opcode operand, that is nothing but immediate addressing mode. Okay. Next type of addressing mode is direct and register indirect addressing mode. So first we will go through definition. Direct addressing mode, the operand's offset is contained as a part of instruction as an 8, 16 or 32-bit displacement. It is given maximum up to 32-bit. As you are aware about 80386 is 32-bit processor. In direct addressing mode, effective address, we already discussed there are three type of addresses: linear address, effective address, offset address. Effective address is nothing but offset address and physical address. Effective address of memory location where the operand is present written directly in the instruction. We will go through examples so easily you can understand. Move ax comma, whenever square bracket is given, it is memory location. So from where data is coming for this instruction, that is nothing but data will come or data will be used from the memory location which is given in square bracket. This will act as a memory location. So data will be accessed or will come from for this instruction from this memory location. So it is nothing but direct addressing mode. That is nothing but in direct addressing mode, the effective address of memory location where the operand is present or written directly in the instruction. That is nothing but memory location is specified as a operand. But remember basic thing, that is nothing but if memory location is specified, from that address data is supposed to be taken and then it can be used for instruction. Just now we discussed move instruction, one of the example for immediate addressing mode. Okay, so I told you that same instruction may fall under immediate addressing mode or it may uh, go for direct addressing mode or any other addressing mode also. Totally depend on for that instruction from where data is available or from that instruction from where data will be taken. Okay, next is register indirect addressing mode. A base register contains the address of operand. So if we will check example, move ex comma square bracket ebx. Very simple thing is given. A base register contain address of operand. Operand is nothing but data. So square bracket ebx, what it indicates? Ebx register will act as a memory location. So whatever content of EBX register for this instruction will act as a memory location, and on that memory location whatever data is available that will be used for execution of this instruction. So getting this point, so square bracket EBX, what it means? EBX, whatever content of EBX, those will act as a memory location, and on that memory location whatever data is available that will be used for execution of this instruction. So it is called as register indirect addressing mode. Next is base and index addressing mode. First we will go through definition. Base addressing mode. Base mode, in this addressing mode the offset address of operand is given by sum of the contents of base register and displacement. So we will go through example which will be easy to understand. So move EAX comma EAX plus 24. See here what a definition given, again we will read so easily you can understand. In this addressing mode, offset address of operand is given by sum of the content of base register and displacement. This EAX is acting as a base register. Displacement is the value which is going to add in uh, or which will be used to increase memory location. So that is direct value which is going to add in memory location. For example, already discussed ki square bracket indicates memory location. So ex whatever contents are there, those will act as a memory location. It will be incremented or it will be added with 24, and whatever address will generate from that address, data will be copied or data will move to CX register. So for execution of this instruction, from where data is coming, that is nothing but it will be by using base register as well as by using displacement. So this addressing mode is nothing but base addressing mode, we can call it as. And remember basic thing, that is nothing but it may called as a base plus displacement. Okay, so basically this addressing mode name is given base addressing mode or base mode, but remember here displacement will be added with base register content and then data will be taken. Similar manner, next is index addressing mode. So an index register contains or index register contents are going to add with displacement to form operand offset. So we will check example, that is nothing but add EAX comma, when variable name is given, square bracket ESI. So from where data is going to copy or from or which data will be used for this instruction, that is nothing but this ESI is index register. So ESI will act as a memory location. This data will be used for execution of this instruction. So these data source and destination are going to add and result will be stored in EX. But remember from where data will come for this instruction, that is nothing but from this memory location which is going to hold by index register. So this name is given as a index addressing mode. Next, scale index addressing mode. So first we will go through definition. An index register's content is multiplied. If it is scaled, already we are knowing is there is scaling factor. If we are calling it as a scaling factor, that addressing mode, scale index addressing mode will require scaling factor. So an index register contents is multiplied by scaling factor which is added to displacement to form operand offset. Okay, first we will go through example. IML EBX comma variable name square bracket ESI multiply by 4. This multiply by 4 is nothing but scaling factor comma 7. Okay, so for this source operand, this variable as well as index register and scaling factor or scaling value is going to use for calculation of memory location from where data is or data will be taken for this instruction execution. So it is called as scale index addressing mode. So again we will go through definition. An index register contents is multiplied by scaling factor which is added to a displacement to form the operand offset. So whatever given after comma, whatever data required for this instruction will be calculated depend on this, and in this index register is used, scaling factor is used, scaling value is used, and because of this it is called as scaled index addressing mode. Next is based index addressing mode. Here now you can assume if name is given base index, base register and index register will be used for calculation or for taking operand from specific location. We will go through definition. The content of base register is added to content of index register to form the effective address of the operand. So we will go through example. Move EX comma square bracket of ESI and square bracket of EBX. What it indicates, that is nothing but base register and index register are used for calculation of the operand value or for accessing operand. These two register will be used, and name itself is indicating which register will be used for operand. So It is index register and base register used for calculation of the operand, or we can say calculation of operand address. Next addressing mode, base scale index addressing mode. The content of index register, name itself index register multiplied by scaling, index, scaling and base, all three. So content of index register is multiplied by scaling factor and result is added to the content of base register to obtain the operand. So remember, name itself will say something, that is nothing but here three register or three factors are going to use, that is nothing but base register, scaling factor and index register. For what purpose though these three are going to use, that is nothing but to obtain operand or to obtain operand address. So we will go through example. Move ECX comma square bracket EDX comma EDX into 8 next square bracket EAX. See here, scaling factor is used, base register is used, okay, and one more register will be used. It may be index register, it can be ESI, it can be EAX. So which register will act as a index register, that is also important. Here it can be ESI, EDI, like that register can be there, which will be used for calculation of the operand address. Okay, and because of that, name is given base scale index addressing mode. Next addressing mode is base index addressing mode with displacement. The content of base register is added to the content of index register to form effective address of operand. Name is given base index addressing mode with displacement. So base index addressing mode with displacement. Direct value is there as a displacement value. So these all content will be used to form or to get address of source operand. Getting my point? From where source operand will come? By using all these three factors, source operand address will be calculated and then data will be taken from this calculation, or depend on this calculation, data will be taken from that location. And because of that, it is called as base index addressing mode with displacement. Base register is used, index register is used, offset value is used, and after using all these three parameters, address will be calculated, and from that address, data will be taken for execution of this instruction. Next is given base scale index addressing mode with displacement. So definition given, the content of index register are multiplied by scaling factor. The result is added to content of base register and the displacement to form operands offset. So move EAX comma variable EDI into 4 EBP plus 80. So name itself is given base scale index addressing mode with displacement. So source operand calculation will be done depend on all these factors or whatever placed after comma. Depend on that, source operand address will be calculated, and because of that, it is called as base scale index addressing mode with displacement. As base register is used, index register is used, scaling factor is used, displacement value is also used, and for calculation of source operand address, these all things are used, and because of that, name is given base scale index addressing mode with displacement. So this is last addressing mode. So basic thing you supposed to remember, that is nothing but how many addressing mode 80386 support, and that is nothing but 11, and how these all addressing modes work. So basic is nothing but one instruction cannot fall under only one addressing mode. It totally depends on from where operand or we can say source operand is coming for that instruction execution. Depend on that addressing modes are there.